Thanks, Frank. So I guess to get this started off, maybe we can start with the folks who are here remotely. And one more time, introduce yourself and, also give us an idea of, what you actually are doing day to day.
I can start. My name is Austin Bradley. I graduated from George Mason 2017, physics undergraduate, and also philosophy. And now I'm not directly involved in a quantum career, but the experience that I got while I was at a quantum company prior to where I am now at Sonatype helped me build skills necessary to do my job now. At Sonatype, I am a solutions delivery engineer, so I help our customers install our product into their infrastructure that helps them protect their software development activities.
Yeah. Yeah. Mahendra, are you there? Mahendra?
Hey, Mahendra, are you here?
Yeah, I'm here. I can barely hear you. So.
Yeah. So if you could just one more time introduce yourself and give us an idea of what you're doing on a regular, in your daily life.
Thank you. Yeah. My name is Mahendra Rangichatri. Originally, I'm from Nepal, and actually, I and Professor Nirmal Ghimere, we were classmates in our undergrad. And I graduated from University of Minnesota in 2019. So I did experimental condensed matter physics. Mainly, I was doing spin-based devices. So the current technology is CMOS. So beyond this, what devices can replace the current technology? So I was working on that, and after graduating in 2019, January, I went to Stanford and I did a postdoc there for about 2 years, and then I joined Intel in February 2021. So I first started as a technology development engineer. I worked for about a year, and currently I'm in the component research where the Intel's research work happens. So the role that I'm currently in is working, continuing my grad school work. Working on the materials, devices, and what is possible technology that can replace current technology. So I work in the magnetic-based devices, or I would say spin-based devices.
Great. Whoever wants to take it next, go ahead.
Yeah, so my name is Sean Oliver. I mentioned I'm an alumni of George Mason, so I was an
I think we're having trouble hearing us.
Yes. So I was an experimental physicist in Dr. Vora's group, studying low-dimensional materials, so two-dimensional materials and nanowires, and exploring how we can optimize those sort of materials for sensing applications and this sort of thing. And then after I graduated, which was in August 2020, actually, I take that back. I started at my company before that, 5 months before that, in May of 2020. So I worked at a company called MITRE, MITRE, in McLean. So we have a few different locations. I'm based in McLean. We also have a large campus in the Boston area, and we also have locations throughout the world. And my role there is a physicist. So I work in the quantum sensing group. And we actually have kind of like in the umbrella of the area in which I work. So we have a quantum sensing group. We have a quantum technologies group that does everything quantum that's not sensing. And then we have advanced materials group. And we all kind of work together. You know, we have some separations. We all work very closely together. And so in that role, and I suppose MITRE in general, so we're considered a nonprofit FFRDC federally funded research and development center. So we work primarily with government agencies, and we sort of wear this hat of like, we're government, we're industry, we're academia, and really what we do is we act as consultants to the government, and we do things like prototype technologies, explore emerging technologies, and talk with our government sponsors about how they can use those for their missions. It was pretty neat, you know, coming from a sort of experimental physicist role and then finding the sort of sweet spot where I can continue to do that, but have some additional sort of responsibilities outside of the lab as well.
I'm Piotr Kulczakowicz. This is Polish last name, originally from Poland. And I'm interim director of Quantum Startup Foundry at the University of Maryland. I'm responsible for building this organization. We're a startup ourselves, running its operations. But my main job is really to attract leading quantum technology startups to set up their business and conduct their business in the state of Maryland and College Park, Prince George's County. Quantum Startup Foundry is funded by the state of Maryland through the legislation. They allocated $25 million over 10 years. No, it's not as much as over 10 years, and there are 3 sections to that funding. Operational budget for Quantum Startup Foundry, Discovery Fund that is meant to invest in economic development in PG County along the strategic directions for industries, including quantum, and 10 million of the 25 is allocated to capital investments, improving quantum assets at the University of Maryland. A little bit about my background. I have masters in applied physics. I spent 1 year in academia in laser spectroscopy. I got my education back in Poland. I also did MBA. It was the first course class of that type in Poland, my university, jointly with business school, HEC, and so on. And I chose to go to a management consulting company. I spent 15 years with the McKinsey company, which is a leading top management company. Traveled the world with them, did different jobs for them, including innovation, counting about 8 different jobs, research, innovation, consulting, you name it. And then I left for a startup that was called Quantum 4D and had nothing to do with quantum. It was a visualization software, or rather visual rates of complex systems, financed by InQtel. InQtel is a venture capital arm of some agency in Sonatype, and then I joined the University of Maryland as a tech transfer function. I worked with about 20 EMD spin-offs in different in engineering and material sciences and so on and so forth. I was managing the portfolio for the university in those areas, including quantum, and that's how I ended up in Quantum Startup Foundry as a program director initially, and when the founding director left, I became an interim. MITRE Corporation is actually a founding member of Quantum Startup Foundry. EY, Management Consultants, is a founding member of the foundry. They really want to be on the cutting edge of the technology, what's happening, how they take it to the clients. And also I'm Cube, which is the first publicly traded pure quantum hardware and software company. And they're located in College Park.
Thanks. So I'm sure there are a lot of questions that the audience will be interested in, but probably the most interesting question, I think, to most people here / attending this virtually is probably, where do you see the biggest career opportunities for people with an interest in quantum? And, everyone's coming at this from different perspectives, so I don't expect that you're all going to have the same answer. But whoever wants to take it first, please.
Yeah, I mean, in my particular case, it's pretty interesting. So we have 9,000 employees. 70% of them have advanced degrees. And what's really cool about this particular job is that, you know, everybody has a PhD in something different, which is really cool. So whenever I work with people on projects, or some people are physicists, some people are electrochemists, some people are lawyers. You know, we have all this like interesting sort of conglomeration of people that all work together, and not only, you know, having all these various expertises, but also your ability to work on a bunch of different projects. I was telling Robert about this earlier. When I first started at MITRE, you know, so I have a material science background. I first started at MITRE. I was working on some hypersonics related things and related to materials. Then I worked on some space applications. And these are the things that, you know, I never imagined I would work on whenever I was a graduate student. Cool. And then after that, now I lead a quantum sensing project. And then I work on an advanced materials project right now. Now I'm also on an electrochemistry project where we're trying to sense contaminants in water sources. So I think, like, you know, you don't necessarily need to have some particularly, like, you can pretty much go to these companies, and if you have some sort of technical expertise in something, and you're a smart person and you're a nice person, if you talk and these sorts of things, they're interested in.
So as part of my job, I talked about now over 100, I would say, startups, ranging from a guy with no idea or really bad idea to a company with sales and substantial private investment. And I also was invited to a couple of panels at different quantum conferences oriented on the business side of things: Quantum Business Europe, Quantum Beach in Miami. And if there is one theme that cuts across all those conversations, is the shortage of talent. And it's not just, they're not talking about quantum physicists. They talk about, you know, anything quantum. I just got a call from a headhunter to join the startup, and with quite interesting sort of incentive package. The point is, we are at the inflection point where people exposed to quantum, having some basics, would be sought after. They are right now by large corporations. Everybody hears about Google, IBM, and AWS and quantum. But you have startups ranging from very small companies to large companies. One of the slides I have, I can show it later. You know, you have, you know, on the one end of the spectrum, you know, you have IMQ with $2 billion market valuation, right? And that grew. The company was incorporated in 2016. In just a couple of years, it's a public company. They have probably close to 100 employees at this stage, and it's not just quantum physicists; it's programmers. It's a wide variety of different talent. But you have smaller companies, you know, single person with an idea, a corporation, just got first funding from the federal government, CTR $265,000 to do R&D on his intellectual property and ideas he has.
I'd like to reiterate that too. For some reason, I can't share my video. I apologize for that. But for me personally, I had a career before I went to George Mason. I joined the Army after high school, and then I worked at NGA, and NGA is a National Geospatial Intelligence Agency. And then I went to do my career in physics, my education, and I did internships at CERN and the Institute for Quantum Computing at the University of Waterloo in Canada. And during my internships, I learned for myself, I did not I was not interested in pursuing a PhD. And after coming to terms with that, and I talked to a lot of PhD candidates and people that had PhDs and had careers in physics, and it's a very legitimate decision to make to not do a PhD, and there's life afterwards if you just have bachelor's degree in physics, because as you guys are hearing, the quantum industry is just going crazy right now, and it's not just, they don't need all just quantum physicists. They need software developers, and they need IT support, and they need anybody that has an interest in or has some background in physics or quantum computing or quantum anything can work in those companies and do other kinds of jobs that don't necessarily require a PhD or even require you to do math every day. So my job after I got my bachelor's degree, I joined a quantum company. They do quantum cryptography. I provided some oversight of their quantum activities, but really my main job was IT and cybersecurity, and that's how I ended up in my job now. So there's a very wide range of career opportunities for, especially because people that get physics degrees are just very capable of a broad range of skills. One thing that I've noticed in all of my career locations, I've always done software development. And that was true while I was at George Mason doing my physics degree. Both my internships and even the classes required software development. So all jobs need software developers. So that's a very valid career path also. So there's a lot of opportunities out there that aren't just strictly quantum.
So Intel is a multinational company. It has fabs in many cities within the United States, in Europe, and in Asia. So we have opportunities in many areas. So to complete the microelectronic devices, physicists, chemists, lawyers, and there's a teamwork. So the jobs that are open in Intel for the physicists are starting from the bachelor's degree, master's degree, to PhDs. The scope of the job will vary, but for the main requirement, so if you have experimental skills, there are a lot of openings. No need to do postdoc. Just from PhD, you can get a technology development, like process engineer jobs.
Thanks. I don't know if you finished or if you just cut off there.
Sorry, I think I cut off here. So for a bachelor's and master's, we have mainly like tool-related jobs, also some opportunities as a process engineer. But for PhDs with experimental skills, there are many developmental jobs that you can do, like as a thin film engineer, if you have experience in the thin film growth or a bulk crystal growth, you can get like etch engineer, you have etching related experience, or also you can do CMP engineering, module engineer. So like there are multiple roles. There are many, like more than 5 modules. You can join one of them if you have experimental skills. As a research and development, we don't have many positions open. It's a very small number. For example, within Oregon, this year may be different. Last year, roughly 25,000 employees there, but like 100 or so R&D engineers. So it's a very, very small number for research, but for technology development, there are many. Not only experimental, but also there are other opportunities for computational. There are like defect analysis group. They usually hire the computational people. Also, there are R&D jobs available for the computational background.
Thanks. So for the folks who don't have eyes in the back of their head, there's a question that's been asked over chat, which is for physics PhD students who are looking to get jobs in industry and are looking, and this is specifically, the question specifically about physics PhD students, but let's just say for students, right, since you guys are answering it. What coursework would you recommend most? You know, what skills do you think are in the most demand? Like I've heard some people say, oh, you know, we really need physicists that understand, you know, some computer science theory or something like that. You know, so what subset of skills do you think is most important?
Yeah, I mean, I could say, so it's actually pretty interesting. In my company, what they want, they have all of us sit in on all of the interviews and give feedback for all of the people that we interview. And you get to have an interesting perspective on what people like about candidates and what people don't like about candidates. And one thing that I've found is it's people who are personable, ask questions, come prepared, and also understand the applications of their work. So, and I mean, honestly, if you just have an answer for that, even if it's kind of made up, because we, like, for instance, this happened pretty recently. We interviewed somebody, and then the question was, you know, somebody asked, what would be an application for this technology that you've been studying for the past 6 years? And, you know, what's holding it back? And then them unable to answer that sort of question is like, oh, yeah, well, maybe they need a little bit more time to think about these sorts of things, or, you know, maybe also a postdoc might do them well. If you want to go into industry, it might be the case that you want to stick with postdoc, right? So, like, understanding how your research sort of fits into the broader area of like applications and this sort of thing, and you can certainly pitch for different things. So in the case of your talk, for instance, we recently had somebody that swapped from my company to like the financial sector, and you know, they're a physicist, a theoretical physicist, and they were able to just pitch their sort of research in terms of like, oh yeah, I can do simulations, and these people love me. You know, they love physicists, so in that sort of area. So like, it's almost like softer skills that you need to develop. I think it's so helpful whenever you start to look for certain jobs.
I'd like to build on your answer actually, because I think you're nailing it. I think ability to be a problem solver. This is not something that they teach you at school or college or whatever. Ability to solve problems, any problems. And I think that's why physicists are actually sought after by different types of companies. I'm just, you know, saying outside of quantum, because inherently you have to solve problems as a physicist, and they are tough. You have to be creative sometimes, and those skills are not. I've been including people to different teams at McKinsey as an example, and that's what we're looking for. Can this guy like think creatively about the problem? And very important also for that creative problem solving skill is ability to listen and understand what the problem is in the first place, ask the right questions, and so on and so forth. So what you were saying is just totally resonates with me. The challenge is, I don't know that there is a coursework that would teach you those skills, but as a physicist, I think you're in a low position to be a good problem solver.
I know everybody at university hates group work, but the reality of your job is that it's all group work. And it's not like forced on you, but it's a collaborative environment and it's fun. And you work with teammates that you get to know and become friends with. And so those are the kinds of things. I mean, you're learning coursework, that's good. You'll take some of that education and apply it in your job. But when you get to your job, a lot of jobs, you spend 1, 2, or 3, or 6 months learning how to do the job. So what you're doing in school right now is learning how to learn. And you should be learning communication skills, how to work with other people, because those are the things that are going to make you effective at your job. And And don't stress about going into a job not knowing how to do a job. At my current job, my onboarding process is 3 months long. It's like very thorough, and they're teaching me everything that I need to know, so that when I go in with a customer, I can either answer all the customer's questions, or I can say to the customer, I need to go back to the right people at my company to find the answer for you. But I mean, soft skills is exactly the right answer for this.
Maybe I'll build on your answer as well, because especially if you are going PhD route, there's a danger that they're very narrow funnel, especially it's so narrow, right? So if you're thinking about what type of coursework to take, maybe you could benefit from expanding your sort of scope, right? So I don't know, philosophy or industrial design. I don't know. One of the startups I've been talking to, the founders, one of them is quantum physicist. The co-founder is industrial designer. Right? And they, I talked to a number of companies that are developing, full stack, half stack, short stack, whatever, software stack for quantum computing. And those guys were like, it was refreshing because they are focusing on the user interface. They want to bring quantum computing to the masses, right? So the guy in the bank doesn't need to know anything about quantum computing, but he has an interface that allows you, enables him, or improves the quality of his work, right? So no coding access to quantum computing. Clever, right? But again, it's this collision of very different fields of creativity. So I think you can really expand your narrow PhD defined area by looking at art, maybe.
I mean, seriously, I was going to say, I also kind of want to speak to that for a second too, because this was a worry of mine when I was in my PhD. I was thinking to myself, and this is, we always make the joke that you're never officially a PhD student until you want to quit. And so, like, I was worried that I was too pigeonholed in my skills, and I had like voiced that several times to my advisor. And what I've found is it's pretty interesting, and I feel like I've heard somebody else explain it this way too. But like, when you're in a PhD, and I keep speaking directly to PhD students, but I think this applies to everything. Which is like, in the case of like PhD, you join a group, your advisor says this is going to be your project. And no one's ever done this before. Like, no one's ever worked on this specific project to really put at the frontier of where that area is. And they just say, all right, go get it. Like, I remember like starting my PhD, and my advisor said, okay, go. And I didn't actually know what I was doing. What do I do? What's the next step? And really what you're learning right there is how to solve a problem that no one else has done before. And like, learn from other areas. You go out, you read the literature, you kind of figure out what other people have done in related areas and apply it here. And what you're doing is like developing this problem-solving skill that the employers actually recognize, and that you may be worried that like, oh yeah, my skills don't particularly fit this application or something like this. But those people that are looking for to hire physicists understand that you're a problem solver, and they know that you'll be able to do this sort of thing.
I actually had an example today in one of the presentations where like expanding your skill set is helpful. There was this design of the coil, right, that was able to get two frequencies of it wasn't paying full attention. But that's a perfect example where understanding physics but some level of engineering and then come up with a solution.
Go ahead.
Yeah, so I will add into it. So there is not a certain course or anything that will get you a job in industry. So what you need to have is group work, as Austin mentioned. So you need to have a good team player, and also you need to keep adding your skill sets, which can be transferable and solve another problem. So in graduate school, you will involve in one project, and you will learn many different skills, and most of them are transferable skills. So those skills you are going to apply in industry to solve higher level problems. My suggestion is that you keep learning all these skills, and most important skills you need to have are group work, and then timing is also very important. You tend to take, actually we all tend to take longer time while we are in graduate school, but in industry there is time is limit, so need to finish the problem in short period of time. You need to be a fast learner, you need to be good team player, and you need to have transferable skills.
I'm not on the panel, but I just want to, I guess, actually say something that follows up on what you said. And maybe speak a bit to the people who want to pursue research specifically as a career. When I was a graduate student, I got a PhD in physics, and now I'm a professor of mathematics and computer science. And during my PhD, I took courses from the math department, the computer science department, the physics department, electrical engineering, and the philosophy department. So, really, especially in a field like this, you're gonna get a lot from a lot of different places, and you kind of don't necessarily know where it's coming from. Anyway, as I said, I'm not on the panel, but I did want to reinforce what you guys were saying.
This is an awesome comment. I mean, think about let's travel in time back a little bit, right? So, Steve Jobs is coming up with the thing, he shows, and it's like, at this point of time, can you imagine something like Snapchat, right? I mean, so now we are at the inflection point, arguably, with the quantum technologies, quantum computing, quantum sensing, and then so on and so forth. Can you imagine, if you have computer sciences now that would benefit from quantum? I actually have one entrepreneur. I think he's from Virginia, local entrepreneur, and he came to me with an idea which is like way ahead of the game, but it's specific application of quantum computing. There's no machine that could benefit from to implement this application. I kind of feel what the application is, but I was like, wow, that's cool. That's something new. Again, someone is thinking a little bit ahead, which, if you are a startup oriented person, entrepreneur, can be dangerous if you are way ahead of the time, like we were with quantum technique.
So I guess I do want to open up the floor for people also in the room and not just open chat to ask questions. So, yeah. Can you, because they won't be able to hear you, can you potentially come up front and just say it?
So, question for you. So, since you talked to, yeah, since you talked to a lot of startups in the quantum space, are these startups kind of like a deep mind where they're just doing a lot of research and then they're trying to sell that and betting that the value is going to increase in 10, 20 years in the future, or are they actually trying to solve a very particular problem using quantum computing?
Both, all the above. I understand your question. We're asking about the scope of those different startups.
Yeah.
Yeah. Very broad spectrum. It's first you start with the field, sensing, communication, photography, computing, right? So it's that, right? Then some of them just work to enable things, right? So prime examples are IonQ or any other quantum computing company that builds hardware, atom computing for neutral atoms, or Pascal, France, again, neutral atom computing, Xanadu, Toronto is doing photonic chips, right? They're building hardware. I mean, the scope is hardware, but there's always a layer of software more important in that control those things and measure. So there's a cluster of people who build hardware that will enable everything else, right? Without hardware, we will not. But but there are people who are like, okay, the next thing that enables is the software, right? Ranging from, hey, how do I control and measure those qubits, right? It has to be very fast electronics. It has to be very fast software to enable what the qubits can do, right? And then, you go through the software stack, all the way to those guys who are doing user interface, right? So they are solving channel problems, if you will. And then you have guys who are focusing on applications, right? So I'll give you one example. Quantum South, it's a startup from University of Uruguay. It's quantum's global business, by the way. And there will be some cool opportunities to go to places if you like to travel, right? Sorry, I'm going on a tangent, but I was on a call today with the Quantum Alliance, and they were talking about like how do we send students, from UMD or the national region to Australia, to spend a year doing quantum at the University of South Wales, whatever. Coming back to your question, so Quantum South is working with Airbus on a very specific problem: how to load the airplane. How to load the airplane. And think about it; it's a very complex problem. You have all those things that you need to send to different places on different airplanes. Every airplane, you want to maximize the weight, but the center of gravity, there's an infinite number of ways to pack the airplane, especially if you have a bunch of airplanes to certain places. Very specific problem, right? There's a small group of people can chase, to speed up Monte Carlo analysis. All those access a large group of people. So those guys are working on very specific applications, right? And so are startups. I mean, I talk to startups that are looking at speeding up Monte Carlo applications, just searching for like holy grail of application for that would be enabled by quantum computing for financial industry. Recently, I talked to a gentleman who's starting a company. He's an expert in computational fluid dynamics, right? How I can enhance software I'm building that is not quantum with quantum. So
Can I ask the person who asked that question, are you asking because you're thinking about starting a company, or are you thinking about working for a startup?
Oh, no, I was just curious. I mean, right now I work at Linux as a machine learning researcher, and I also do photography research here at GMU. So that's why I was particularly interested in that, because I think like one of the things that we've kind of seen with machine learning is in many ways I don't want to say this in general, but in some ways the state of the art machine learning has shifted from industry to small startups. I mean, it's kind of shifted from academia to small startups and big industry. So I was kind of wondering if there's that trend that's shifting from academia to startups. So that was my curiosity on the question.
I mean, what we do is we interact with a lot of people who eventually. It's pretty interesting. So our sort of like one of our jobs is to keep abreast on these various quantum technologies, and then give our access to government sponsors and so on, learn about applications, and then make those connections. And so we've done that recently, for instance, working with an academic partner, working with the government, figuring out how those two technologies work together, and then a startup company comes out.
Other questions from the audience? Yeah. Can you just come up to it?
So I'm interested in basically moving towards a master's in physics or something related to software engineering and physics. And my question is, if my focus is moving towards the industry, do you think a physics PhD would be worth it, or would a master's in a related field be equivalent?
I think one of the presentations yesterday had a very nice matrix skills aspects of the quantum industry. So if you haven't seen it, I recommend that you have a look at it. I think at the end of the day, it's a visual answer. I mean, in my case, you know, I did my master's, and the professor said, "Hey, join me. You know, it's cool. There's this." You know, totally. It was totally cool. I loved it. I loved every moment of it for a year. But you know, I had to make a decision. I mean, because I also keep this new exciting world. You know, going through the market economy change. It's like, wow, that's kind of interesting, and it's like, and I put it that way, and I don't regret. But looking back, I know that if I had PhD in physics, I wouldn't regret either. See what I'm saying? It's just like, but you can have both. I like to this proposition.
Yeah.
Anybody else? Sorry.
No, because I was just specifically like, because I talked to some people like the physics PhDs, and they told me that so they're overqualified so for some positions. I'm just curious to see if that's like a common theme.
Frankly, I don't understand what overqualified means. If a recruiter tells you you're overqualified and they invite you, I don't get it. I mean, it's like you're either the right guy for the job or not. I mean, and then, you know, coming back to your better, so when you get to the top of the road, take it. You know, it's like, go left or right.
I think in particular right now, because of the quantum inflection point, and there's so many startups just looking for people that have quantum experience, they value having PhDs on staff just because it makes them even more expert to people looking from the outside at their company. So I definitely, I agree with you. I feel like in the past, I've heard people say, there's been some concern about PhDs being quote unquote overqualified for a job and they won't get hired. But I think right now is different because of all of the emphasis on growing everything quantum right now in all the startups.
Probably done this too, but I would recommend poking around on things, you know, like LinkedIn and Indeed and Glassdoor and all these, looking at the jobs that you're interested in and looking up the sort of requirements that they usually list. If you just look up enough of them, you'll kind of get a feel for what sort of things you need. Because, like in a lot of cases, when I was looking for jobs, you would see things like, you know, it would be nice if you have a master's degree, that's a medical requirement, but your preferred applicant is. Those are the things that you look around and just get a feel for.
Thank you.
Before you go, does anybody else have a question since you already?
Yeah. So, in terms of like the way that we, I guess in transistors and in semiconductor, we have Moore's law. Is there the equivalent of Moore's law for quantum computing? Are we able to say that the cost of quantum computing has decreased significantly?
I believe I've seen a chart that will resonate with the question, but I'm unable to recall it from my memory. I think someone has just come up with a version of, you know, the Moore's law chart, extending the Moore's law charts. And I just felt like within the past 2 weeks, and whoever made the chart, this person implied that it applies to.
So
I think
you're talking about when you say that there's an inflection point, is that being the
Well, no. The basis for my comment about the inflection point is simple. From a company, McKinsey company, they put together a couple of reports on quantum computing specifically, and there's this one chart where it shows investment in private investment, like companies. Not talking about the government funding, and you know, it just went like this: $1.7 billion in 2021 invested in businesses that took form from, right. You have Rigetti's public, Landfill public, then you look at constraint, but other companies are a bunch of startups are very well funded. I think a lot of people in the investment community, they're expressing worry about over investing in quantum. There's no hype. Some companies maybe shouldn't be as well funded as they are, and because there's this good about the whole thing, including this isn't going to work.
What?
Yeah, go ahead.
I'm following on that, and also the question about Moore's law. I think it's a little bit challenging to answer that question because it's so early still, really, from the big picture in quantum computing development that not even the best qubit has been decided. Some people do superconducting qubits, which are probably limited by all the wires that have to go into the cooler for controlling. Microsoft finally has a successful topological qubit, so that could be a different density for qubits. IonQ is doing their thing. So with ions, so even being able to define what a Moore's law curve depends on the type of qubit that is successful in the end, probably because there's only going to be maybe one type, just like there's only one kind of transistor on silicon. Yeah, I had another thought and I lost it, but that was what I was thinking about that.
We've got another question online, so before we thank you, how much time do we have? 2 minutes. All right, so let's try and make this one quick. Let's try and hit it.
Yeah, I can read the interview. Yeah, so I wanted to ask the panel for technical interviews, which are typically in front of engineering and non-physicist audiences. Are there any suggestions or advice you can provide for framing or presenting projects that may be limited in engineering or design aspects, but involve novel physics? And what aspects of the work do you feel best sells us to potential hiring managers?
So it depends. If it is for research and development position, you will want to talk about novel physics, novel design. But if it is for technology development or process engineering position, you want to talk more about the problem solving. One problem that you solve. Suppose your tool is down, what you have done to bring that tool up, that sort of thing. That you can put in your presentation.
I agree with problem solving because they're not necessarily going to understand the subject, but you can describe how you think, and that's really what they're trying to understand. Because when they hire you, you're going to be solving problems for them, so they want to understand your thought process. How did you analyze the problem? What approach did you take to come up with a solution? How did you implement your solution? What were the results?